So welcome to this week's Gardener review meeting. Today we will look at the recently released 1.130 version, and we have quite a bunch of topics. We start with two topics related to VPA. So first one about the recreate mode from Stoyan. Then Rada will show us improved recommendation monitoring. Then we have a new small features presented by Marine for the extensible advertised addresses and the should status. Finally, Tim Ebert will show us the progress on GAP28 with the gardenadm bootstrap command. Then we have Lucas with a new feature gate, UseUnifiedHTTPProxy. Plamen will show us a bug fix for secret restoration during control plane migrations. And finally, we have another bug fix presented by Oliver for the multi-zonal L7 load-balancing. All right, then Stoyan, please get started with the first topic.
Hey everyone, let me share my screen. Okay, hope you can see it. So with the new 1.130 release, we are adopting the new version of VPA that deprecates update mode auto. We had a discussion with the upstream folks that maintain VPA, what's the purpose of auto, and it turns out that it has always been a placeholder for recreate. So now that it's being deprecated, we took on an initiative to migrate from auto to recreate. The main purpose is that in the updater logs, using update mode auto with your VPA, you'll be flooded with deprecation messages, which will just make the log unusable almost. So we took on initiative. We updated all the Gardener managed VPA resources, and we are slowly rolling out the extension one. So be mindful when you use update mode auto. We strongly recommend to switch to recreate for your new resources, or migrate your current ones with the proper recreate mode. So that's pretty much from me. Just a heads up for you guys.
Okay, all right. Thanks, Stoyan.
Thank you.
Any questions? No, then over to Rada for the improved monitoring.
Yep, thank you. Just a second. Do you see my screen?
Yep.
So here's the port forwarded operator local setup Plutonal dashboard. For this one is for the VPA recommendations. Actually, here the issue that started it all was something that Victor brought up, because he wanted to be able to define how close the VPA recommendations are to the actual CPU utilization, and do that for a certain period of time, and be able to modify this period of time, modify the deviation we're trying to allow the VPA recommender to have from the actual CPU utilization. So here, if you want to delve a bit more in depth on the problem that we were trying to solve, here's like a more, I would say, more mathematically explained solution, but in a simpler way. I'd say we're just looking for this interval D, which is the time range, and we have this parameter R, which is the deviations that we are allowing from the CPU recommendations. So our first approach was actually to define parameters Prometheus rule. But then again, it would have been a bit too much to define a simple rule for this. So we tried adding it in the dashboard. I actually had like little experience with Plutono dashboards, but again, thanks to Stoyan, I managed to understand how I can do that. So thanks to Stoyan also. And actually, the VPA recommendations, here I've forwarded the Plutono overshoot just to show you. In the operator local setup, you can see here in the last hour, we had continuous underutilization. So here you can actually see some of the Kube API servers, but still you can target a lot of other stuff. It's not limited just to the Kube API server, which I think is a nice addition. And you can set the deviation duration that I talked about earlier, and also the deviation tolerance. So we've allowed like a certain amount of stuff. We're open to adding more, but I think it's a great start in order to monitor future VPA degradations maybe, or some kind of regression, or maybe even load balancing. And I'd say this is it from me.
Thank you. Any feedback or questions? Nope. All right. And next one is Marine with the extensible advertised addresses.
Mute. Hello, everyone. Can you hear me?
Yes.
Yeah.
Okay, and the screen I hope is visible as well. So I'll just get started. Okay, so today I will be presenting this new feature which landed a couple of weeks ago in Gardener. It's called Advertised Addresses for Shoot Ingress Endpoints. It's quite a long title for a small feature, so I'm just going to walk you through it now. You can see here the initial proposal where we have been discussing this. This is also the linked pull request which implements it. You will also find documentation in the docs development section where you can find more information about this feature. So instead of just reading through it now, which you can do offline, I will just show you a quick demo of what this is about. I have my local setup here up and running, and my shoot is in healthy state, which is great. So one thing that you might already know is when you're getting the shoot specification, you have a field which is called status advertised addresses. So if you get this one, what you will find here is a list of endpoints. For example, you will be able to find the endpoints for the API server. You will also be able to find the service account token issuer, which is what you're going to be using when you want to establish, for example, OpenID Connect trust between your cluster and a third-party service. However, these are not the only endpoints for the shoot cluster, because when we check the, okay, let me just get the ingress. When we check the shoot control plane namespace, we will see that we have a bunch of ingresses as well. And usually those one, the logging, Plutono, Prometheus, you already know because you can see them in the dashboard. However, they're not part of this list, which means that if you don't have access to the seed and the respective control plane of your shoot, you have no idea that there is actually a new endpoint that you can access. So what we decided to do is implement a feature which allows us to label an ingress, and then the gardenlet is going to add the respective endpoint to the list of advertised addresses. The nice thing about this one is that you can now have separate controllers which contribute to the list of those endpoints visible for your shoot cluster. And the only way to do it right now is if you actually use this label in particular, which is called endpoint.shoot.gardenercloud, advertise equals true. And if I just label one, let's say to label, let's say that I want to expose the Plutono, what I will do is label ingress Plutono, pass in the label equal true. And now what is left to be done is that you need to reconcile the cluster. So I'm just going to quickly schedule reconciliation. And if I go back here and again check the status advertised addresses, I should see a new endpoint coming out. And as you can see here, we have the new endpoint here. Now, as I mentioned, external controllers can contribute to this one. Just to give you one example, this is the OADC apps controller, which creates ingresses. The dashboard knows about those because it has a special logic to handle those. But the whole idea is that when you have a new controller, you can actually just label it and let the gardenlet contribute or actually extend that list. Another thing that is worth mentioning here is that today only ingress resources are supported because that's what we have. But in the future, when we have gateways, we will also be getting support for gateway APIs. And we are also thinking about further extending the structure. For example, instead of having a name and a URL, what we might be adding in the future as well is additional metadata like what is the purpose of the endpoint, or for example, what kind of category does this endpoint fall into, which is going to allow users to pretty much filter, get whatever they need from this one. And I think that's it. I mean, as I mentioned, long title, small feature. Thank you.
Cool. Thanks, Marine, for showing this. If there are no questions, we directly continue with Tim in GAP28.
All right. So I'm presenting the latest enhancements of GAP28, which are the autonomous shoot clusters. I mainly worked on the medium touch scenario, so where Gardener manages the infrastructure for you. And we have this command gardenadm bootstrap, which is the simplest way to get started with autonomous shoot clusters. And what we have seen so far in previous demos are basically all of these changes right here. So Gardener provisions infrastructure and worker using the existing Gardener extensions and machine controller manager. And it also installs gardenadm on the control plane machines so that we can initialize the control plane. I will present the latest changes right here. But because the process takes a bit longer, I have already executed gardenadm bootstrap before, so that I can show you the results. You can also try this out by checking out this guide. As usual, you just start with a kind cluster, which we also call the bootstrap cluster in the gardenadm bootstrap command. And then you will find the commands to execute under the medium touch scenario. So this is what I did, and I will walk you through the results. So as you can see, the command finished successfully. And we now have a few components already running. So first of all, Gardener Resource Manager, which deploys the local extension. But we also have the worker. It creates one machine. Its status is available. So this is different compared to the normal setup where it says like pending and then someone running. In our case, the machine controller manager runs without a target cluster because there is no target cluster, right? So the first difference we can see is that in the machine status, there will be a new section called addresses. It contains the host name, and depending on the provider implementation, it can also contain internal IP, internal DNS, and other stuff. So gardenadm bootstrap will pick that up to connect to this machine for bootstrapping the control plane. And it also uses this particular IP to provision a DNS record, which we can see right here. So this is the domain that is specified in the shoot spec. As usual, DNS domain is the field. And then in the DNS record, there should be the IP that was reported by the MCM provider. Okay, this is internal for now. We can not exit it from the outside, well, but this will be implemented later on. It's sufficient for Bootstrap purposes. Okay, then there is another component involved here, which is the bastion. We already know the bastion feature from gardenctl SSH. We just reuse this one. So there will be a bastion object, and the provider extension is instructed to provision a VM with a public IP within the worker network. In the local setup, this is similar to how we actually deploy the machine. So there's just another pod, even using the same image, and there's just an SSH daemon and key on it. And we do some magic port forwarding and IP stuff because there are no load balancers or public IPs in the local setup, obviously. Okay, but once that is all ready, gardenadm bootstrap will connect via this bastion host to the control plane machine. And then it will basically copy the manifests and so on that we need to initialize the control plane. So when we get on this machine, we should see var lib gardenadm. Whoa, let's try that again. Gardenadm, and there should be the manifest folder. This one contains the manifest that we have given locally when starting gardenadm bootstrap. So in it, there should be the shoot spec, the cloud profile, the extensions, and so on and so forth. So everything that we need to bootstrap the cluster. And there's also the shoot state, which is new. You already know the shoot state resource from the control plane migration. We use this for persisting all the state that we need to restore on the other side of the operation. It's quite similar here because we have the bootstrap cluster that has the secrets and state of extensions and machines, and we want to import this into the autonomous shoot cluster because at the end we want to throw away the kind cluster because it's only used for bootstrapping purposes. So there's the machine state and some secrets in here. And when we check the autonomous shoot in a few minutes, we should see that this particular SSH key pair secret was restored in the cluster so that it is not regenerated and we don't lose access to the machines. Okay, so once gardenadm bootstrap has provisioned all of the manifests and the shoot state, it will basically run gardenadm init on the machine so that the control plane is initialized. And if that is successful, it will store the resulting kube config in the bootstrap cluster so that we can get easy access to it. I will just extract the kube config from the secret. And because the DNS record is not reachable from the outside yet, I will just rewrite it to a local host so that I can do a port forward of the machine. This is just temporary for the demo. But if I now use this kube config, I should be able to access the autonomous shoot cluster for the first time. So here's the node. There should also be the control plane components running as static pods in the kube system namespace. You will find etcd and also kube API server and so on and so forth. What we should also see is the secret that I showed in the shoot state. So as you can see, it was successfully imported like all of the other secrets so that we don't regenerate all of them. Okay, so that's the current state of gardenadm bootstrap. Just a short outlook, what is next? So apart from the secrets, we also need to deploy and restore the infrastructure resource and the worker and the DNS record that we used in the kind cluster. so that they can be managed from inside the autonomous shoot cluster, because that's our ultimate goal, right? To have a managed infrastructure within the cluster. And then we can also import the worker and the machines and so on, so that we can join more nodes. For now, there's only one, the first control plane node. But once we manage worker and OSC from inside the autonomous shoot, we should be able to join more nodes automatically without the user interaction. And then one step that is also missing is to expose the API server for external access. For now, the DNS record just points to the internal IP, but we also want to access it from externally, obviously. So that's where we stand, and I guess we will see the progress in the next review meetings then, hopefully. Any questions to that?
So gardenadm connect is listed here in the end-to-end test task. Do you also plan to run it regularly when you, so as part of the bootstrap command, you already run init? Do you also plan to run connect there?
I guess we can't run connect in this whole process, because after initializing the autonomous shoot, the operator first needs to deploy the garden, and we don't have any resource for it in this whole bootstrap process. Maybe the autonomous shoot doesn't even run the garden, depends on your use case. So yeah, we could think about making this easier, but I guess for now we should tell the operator to run gardenadm connect on their own later on.
Okay.
But obviously, we want to make sure that the autonomous shoot that we provision with gardenadm bootstrap can be connected to a Gardener instance. So that's why we should run it in the end-to-end tests.
Yeah, sure. All right. Any other questions? Nope. Then thanks, Tim. And over to Lucas for the unified HTTP proxy feature.
Thank you very much. So I will grab the, oh, I cannot share my screen.
Sorry, I have to promote you to a presenter. Now it should work.
Thank you very much. So today I will present a bit more about the progression we made in the GAP 30. So we introduced a new feature gate called UseUnifiedHTTPProxy port, which is part of the goal from the GAP to unify the proxy infrastructure across Gardener. So when this feature gate is enabled, the Istio gateway will have a new port called HTTPProxy, which is using the 8443 port as a listener. And also there are new envoy filters and Istio gateways to expose this port for usage in the VPN. As you might see, there's also this old 8132 port still available, so we are in the process of transitioning from this old port to the new unified port. But this feature gate is just about adding this new port into the service. So when I'm in my local setup right here, so if I now check my my envoy filters, so there is a new gateway called HTTP Connect, which is used to expose this port on the Istio gateway. And also here is this was previously the reversed VPN off service. Now it is using a non-existing black hole because this is necessary by the Istio CRDs. So don't be fooled, this does not exist. Otherwise, there is a new entry in the reversed VPN envoy filter, which now matches the new port, so the 8443 port. And this is basically the same as we did before for the VPN, but we are now using a new header, which is called xgardenadm. And this is also configured on each VPN client inside the chute. So if a gardenlet reconciles the chute with the feature gate enabled, it will deploy the VPN with the new header configuration. So it will send this new xgardenadm header instead of the legacy reversed VPN header. It basically functions the same, it's just a different name. What's also new, if this feature gate is enabled, Gardenlet will report a constraint on the chute. So if we describe the chute, chute. Where is it? Yep. And view the constraints, we see that there is a new constraint called UseUnifiedHTTPProxy port, and this is set to true or reported when the feature gate is enabled. So later on, we want to use this constraint when we drop the old port to check whether all chutes already use the new port, so that we can safely drop the old port. Yeah, and this is the plan for the future, but for now, this is where we stand. Any questions?
Nope. All right. Then thanks, Lucas, for presenting this. And next one is Plaman with the secret restoration during control plane migration.
Hello, so let me share my screen like this. Yeah, so the initial work, or the starting PR that led to the development of this secret restoration is the fact that we had to restore the worker pool's operating system config hashes secret, which seemed to not be correctly restored during the restore phase of control plane migration. Just real quickly, so the secret is used to map the version of worker pool hashes to each worker pool and to each operating system config key, so that we know which version of the worker pool hash calculation function is currently used. And we need to restore basically this during control plane migration, so that workers do not get rolled out during the restore phase. And this rollout was currently happening because the worker pool hash version 2 function was used if for all worker pools if this secret was not present. So because in order to save time, I already set up 2 seed clusters with the local setup, created a chute. And here you can see in the source control plane, basically we already have this secret called worker pool operating system config hashes. It has some data, and I also added this demo label to demonstrate the restoration. Because for local setup, it could happen that we always use the v2 hash to calculate the worker pool hashes, so this would not cause like any restoration, and the data here might be the same. So here I will now trigger control plane migration with this command. Okay, that's running, and meanwhile, while we wait, just show quickly what is happening and what exactly was the issue before. So as I said, what we want to happen is we have the secret in the old or the source chute control plane. We want to somehow persist it, which is happening by saving it in the chute state when the migration starts. The chute state was already shown by Tim in his demo. And here one important thing to note is, maybe I can zoom out a little bit, zoom in, a little bit. So this, any secret currently that has this persist true label will get fetched by gardenlet and saved then in the chute state when the migration phase of control plane migration is triggered. If we go to the shoot state, the shoot state itself has this gardener field inside the spec, which contains an array of resources that are persisted. So currently for secrets, we persist the data. Here you can see this postings that is also saved, which is also present in the secret. And we also persist the labels. So we would have the persist label, and we expect to also have this demo label that I added for the demo, and of course the type. So what was the issue before? So previously we also have this secrets manager library, which was adding secrets here, and they also had one more label, which was called managed by secrets manager. And actually when the restoration phase started, so basically here, only secrets that had this managed by label were getting restored. So essentially what the PR changes is that it now no longer looks at these labels when it does restoration. It just assumes that if a secret was persisted with this persist true label, that it should be now restored. And this is what it does. And again, it restores everything as it should be with the labels, with the already existing labels and the existing data. Okay, so then let's go back to my demo environment. So here in this second window, I've targeted the destination seeds. First, let's maybe get the shoot to see its current state. Oops. Okay, so restore is already processing. So as I said, this happens, the restoration and secrets happens at the start of the restore, so the secrets should already be present here. And here it is. You can see that the label got persisted. The data is also the same as the one above, but as I said, because of how the local setup currently works, we do not expect anyway any changes here. What was the important part was the persistence of the label for the demo purposes. So yeah, that's all from me. If you have any questions.
Yep. Cool. Thanks, Plamen. And then our final topic for today, presented by Oliver, about the L7 load balancing fixes.
Yeah, hey, good morning. I'd like to present another small topic about the layer 7 load balancing. You might have heard about it. We tested this load balancing a couple of times in our landscapes, and we were not really satisfied on all occasions with the results, and but we didn't know why this was happening. And finally, Victor found a bug. We did not discover so far, and this was this bug occurred in every of our test cases. Okay, so let me start here. So the layer 7 load balancing, I give a kind of context here. The layer 7 load balancing tries to balance the load between all Kube API server instances, and in case of the multi-zone setup, we have usually only one Kube API server instance per zone, and that's and we have a second feature which is called topology aware routing, and those two features were interacting in a way we did not foresee, or we did not plan. So basically the issue was that topology aware routing was activated for the Kube API server services. If you don't know how this is done, this is here this traffic distribution prefer close. And yeah, this was set for when in the multi-zone setup and when the topology-aware routing feature was activated. So Istio honored this setting, yeah, and it was basically just load balancing to one instance in this case, and this was not a good result. Yeah, this we did not discover this in the local setup because of different things. Yeah, this is fixed now. I don't have a demo for it, but yeah, and this hotfix here, the first hotfix, it was a bit too hot, and it deactivated the topology-aware routing in too many cases. So there was a second hotfix which fixed the two. And yeah, the good thing about this is now we have also introduced a hint here in the topology-aware routing documentation, which mentions the layer 7 load balancing here and what users should expect here. For example, for the Kube API service of the shoots, and also for those here in the virtual garden. Yeah. Okay, that's already it. Any questions?
Again, no questions. Perfect. Then we are at the end for today. Thanks everybody for presenting, even if it were small things. Really nice to see. And yeah, with this, have a nice time and see you again in 2 weeks. Bye-bye.
Bye-bye.
Thank you.
Thank you. Bye.
See you.
Bye.